Hi all, this is Yann for Confling, and I'll be talking about typing in configuration languages, and more specifically in Nickel, which is a language we are developing at Tweag. And let's start with the classic holy war between static typing and dynamic typing. So dynamic typing is usually more flexible. You can write any program that runs fine whatsoever. Static typing is more rigid in that it requires annotations and will reject some valid programs. However, the price to pay for this flexibility is quite high, both in code clarity, code readability, and more importantly, in error reporting and debugging capabilities. And this means that usually static typing is winning for standard programs for any non-trivial project. However, configuration languages are a bit specific. In particular, a configuration program usually has a terminating run on fixed input. Those languages are pure, so once it got its arguments from the outside, there is, so to speak, only one code path that is triggered. And this limits the dichotomy between reporting error at compile time and reporting error at runtime. Also, there is some kind of implicit separation between computations, which is what those languages add over JSON, and data, which is what most DevOps will write, which is basically JSON, plus sometimes you can use those facilities of computations. And if you are going to validate those data, then adding static typing on top of that is less useful than for general code. However, still dynamic typing doesn't scale, or at least traditional dynamic typing. So this is an example of Nix, so my own configuration I wrote at some point for my system. And I did an update and I got this really strange error, which is infinite recursion and some internal Nix stuff. And what happened is that one of the name of the arguments or parameters of my configuration was off. I put an S in the wrong place. And I had this awful error. And the point is that with dynamic typing, the error isn't triggered when you build a faulty value or when you do something wrong, but when this thing is actually used possibly way later in some different part of the program, which makes for bad reporting. So that just says, let's add static typing to configuration. So this brings all the usual benefit of static typing. Some of the shortcomings are that it has limited type inference because of its very powerful type system. If you have to interact with untyped code or an unstructured JSON, then it can be a bit painful. And also types are limited for general schema validation. Checking that something is a valid port number is quite hard to do statically. In Nickel, we went for what we call contract, which is some kind of principal and first-class dynamic typing to check that configuration code are valid with respect to some schema. And once we had contract, we relaxed typing because once again, having static typing on top of contracts doesn't add a lot for configuration code. So we can accommodate untyped code, we can do validation inside the language, and have nice error message because of annotations and built-in error reporting. Shortcoming can be the temptation to just not type anything, so I think it can be fought by culture, documentation, existing code, community, but this is something to keep in mind. And contracts, in particular, some contracts that are automatically inserted for gradual typing can have a runtime cost. And this is not clear yet if this will be a huge problem for configuration code. Q is a bit different. It takes the stance that configuration ought to be way simpler than general code, and so it limits computation. You don't even have general notion of function. It limits overrides or inheritance, taking a configuration and changing a value, and and with a very well-behaved and simple system, both for tools and for humans. However, this limited computation, which is both the perks, is also shortcomings, because when you need to go outside or to these things that are not in the original framework, then you kind of hit the limitation of this tool. So the main takeaway is that configuration language are peculiar, that allows to try different trade-offs, and still traditional dynamic typing doesn't scale. So DAL uses full static typing, Nickel uses those contract and say, okay, we don't need static typing anymore, at least for configuration, so it has gradual typing. And Q is just very different, with a much more restricted system where everything is a type, basically, in exchange of good behavior. So I'm very excited to see how those languages will evolve, and thanks for listening to me.